Our final unit for advanced algebra is on logarithms. We are going to solve problems like this. So 2 to the x equals 4. So I need to figure out what power do I raise 2 to get 4. Well, that's not too hard because we know that 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. So here's my answer right here. So I know that x equals 2. What if I had 2 to the x equals 32? So this one's a little bit trickier because we've got to do a little bit more work. Since 2 to the second was 4, 2 to the third, which is 2 times 2 times 2 is 8. 2 to the fourth is 8 times 2, 16. And then 2 to the fifth is 32. So here my x value is 5. 2 to the fifth power is 32. What if I wanted to figure out what power I'd raise x to get 20? Well, 2 to the second was 4. 2 to the third was 8. 2 to the fourth was 16, almost there. And 2 to the fifth is 32. So I don't have my answer because it's somewhere between 2 to the fourth and 2 to the fifth. So what I can do is I can use my calculator to help me find decimal approximations, and I can try 2 to the 4.1, 2 to the 4.2, 2 to the 4.3, 2 to the 4.4, and I can just keep going until I get close enough where it rounds to 20. That's a lot of work for us. So we're going to take exponential problems where I don't know the value of my exponent, it's my variable, and I'm going to turn them into logarithms. So let's say we start with any exponential problem, like b to the x equals a. Some base b is raised to some power x, and it equals some number a. So this is exponential form because I have an exponent. We're going to rewrite this exponential problem as a logarithm. So we abbreviate logarithms with the word log. Base b, this is the base of my exponential, is the base of my logarithm, of a equals x. So this is logarithmic form. Exponential form has an exponent. Logarithmic form has a logarithm. Notice that my exponent in exponential form is what it equals in logarithmic form. So I like to say that it equals the exponent. The logarithm will equal the exponent. The way that this logarithm reads is log base b of a equals x. So the base of my logarithm is b. That's the same base that I have in my exponential. B to some power, log base b, of a equals x. Again, it always equals whatever the exponent is. So we're going to practice rewriting from exponential form to logarithmic form and vice versa. So here are 4 problems. I'm going to write these from exponentials as logarithms. So the first one, I'm going to write my log. The base of my exponential is 5. That's what I'm raising 5. I'm raising 5 to some power. So the base of my logarithm is 5. That makes it small. Of 25 equals x. It will always equal the exponent. Now I'm not going to solve this. I don't really care what x is at this point, but at some point we'll find out what the x value is. For number 2, I have log base 7 of 14 equals x. Again, the exponent goes to the end. For number 3, I have log base 1/2 of 4 equals x. It is okay to have a base as a fraction. And then number 4, I have log base 16 of 4 equals x. So here we have 4 logarithm problems, and I'm just going to rewrite these as exponentials. Again, some of them have x, but I don't really care what x is. I'm just rewriting. So for number 5, I have 4 to the second equals 16. Remember, it always equals the exponent. For number 6, I have 10 to the third equals x. Again, 3 would be my exponent. For number 7, I have x to the second equals 25. 2 is my exponent. And then number 8, I have 3 to the x equals 27, where x is my exponent. So in a logarithm, it always equals the exponent, and it's always easier to solve, in my opinion, an exponential problem than it is a logarithm problem. But the calculator will do all the work with us for logarithm problems.